Everybody, so here is your Chapter 5 test review. I'm just going to use version A, but all of them should be similar enough. Just let me know if you have any additional questions. So first question is asking for a right-hand Riemann sum from -2 to 5 of capital F of x dx using 4 subintervals. So we are going to use, for part A, we are going to use information from the table about capital F. We are going to remember that we're looking for rectangles, right, from -2 to 5, and we're coming up with 4 of them. But because we don't have a function, we are not going to be finding a universal or a uniform delta x. We have to take a look at how much does it change between each of the two x values. And we will do 4 different areas of rectangles using width times height. Okay. And if we're using right, each of these pairings, so -2, 9 is an ordered pair, and -1, 6 is an ordered pair, 6 would be the right approximation for the first rectangle. So the distance between -2 and -1 is just 1 unit, and it has a height of 6. And the distance between -1 and 1 has a distance of 2 and a height of 6 again, because we are using the next right ordered pair. And the distance between 1 and 4 is 3 and a height of 21. And the final one, from 4 to 5, is 1, but a height of 86. So if we multiply the widths and the heights together and we add them all up, you should get an answer of 167. So the second question is asking something similar, but using different notation. And in this one, we're not doing a right-hand Riemann sum or a left-hand Riemann sum. We are acknowledging that the integral of big F prime would be equal to f of b minus f of a, or f of 1 minus f of -2. So again, we're pulling information from the table of values from the regular capital F function, not the capital F prime. And these values that we take are the y coordinates at 1, which is 6, minus the y coordinate at -2, which is 9, giving us -3. Okay. So question 2, I think a lot of us made the mistake with how to deal with that water leaking out at a rate of 5. So water flows into a reservoir at a rate of 5 plus t cubed gallons per hour. So that is a rate, a derivative. There's a tiny hole, so the water is leaking out at a rate of 5 gallons per hour. We're not going to include that as a 5t, it's just simply a 5. So there's 2 ways to do this. You could say, well, my rate equation is 5 plus t cubed going in, minus 5 going out, which simplifies to t cubed. Or you can just work with the 5 plus t cubed and then deal with the 5 later on. Totally up to you. I tend to deal with the 5 later on, but you don't have to. So anyways, we want to know how much water is in the reservoir at time t is equal to 2. And we are told that at t equals 1, there's 100 gallons in there. So we need to get this rate equation back to some kind of quantity type equation. So I need to integrate dt with respect to dt. So I tend to write it as an indefinite integral. I integrate by hand, which means I go back to 5t plus t to the 4th divided by 4 plus a c. Okay, so I am told, so this is my quantity equation, whatever I want to call it. I'll just call this big F, okay, of t. I'm told that at 1, there's 100, so that allows me to figure out what my C is. So C is 100 minus 5 1/4, so it's 94.75. Okay. That's my C value. So now I can go back and say that, well, my original equation, my quantity equation, is 1/4 t to the 4th plus 5t plus 94.75. Right. I want to know what's going on at 2. So I would have 2 to the 4th is 16, divided by 4 is 4, plus a 10, plus a 94.75. So that should end up equaling 108.75. From there, I then need to, if I do it in this way, I need to realize that, okay, water was leaking out. So between hour 1 and hour 2 is only 1 hour. So I only need to subtract away 5 gallons to get my final answer of 103.75. Now, there's definitely other approaches here. Like I said, you could have taken the 5 away at first and only anti-derived the t cubed and wouldn't have to deal with it. You could write it as 100, which is my initial condition, plus how much water accumulates from 1 to 2 of 5 plus t cubed minus the 5 dt. This would give you the exact answer right away. But it takes a little bit more understanding of your notation. Okay, so the first way I did it is like step by step, finding the original equation, figuring out the information when t is 1 and it's 100 gallons, etc. Whereas this one is certainly more direct, but you need to understand that here's my initial. I'm only accumulating from 1 to 2 of my full rate equation, taking away what's leaking, and then I could get my final answer. Okay, question 3, distance traveled, which means we need absolute value. And how do we deal with the absolute value? The absolute value, there should be a t by the way, the absolute value needs to be around the velocity in the integral. So it's integral absolute value 4 minus t squared dt from 1 to 3. You absolutely could have math 9'd this. I didn't say you couldn't. If you did not, what you need to acknowledge is, first of all, well, this normally is the parabola like this, with -2 and 2 being our x-intercepts. We only want to go from 1 until 3. So we need to realize that over here, in between 2 and 3, we need to reflect. Right? This is the area that we don't want. This is the area that we do want. So that would give us 2 positive areas. So if we're doing it by hand, we would be setting up 2 integrals from 1 until 2 of the original equation, 4 minus t squared dt. And then you can either subtract the other integral or apply a negative to the equation. So plus 2 to 3 of negative 4 minus t squared dt, because I am reflecting it. So doing it by hand like that, you'll get an answer of 4. Of course, if you type it in the calculator exactly as is, you'll get an answer of 4. Question 4. Okay, this is one you guys have to get down pat. It should be simple. You need to recognize deriving an integral. This is FTC Part 2. Essentially, you're not doing anything unless it's a chain rule being introduced. So we are inserting, substituting the upper limit for the t, or the limit that has the x in it, I should say, 2e to the sine of 3x squared. I don't care if you simplify that or not. And then you have to multiply to account for the fact that it's a chain rule. You multiply by that upper limit prime. So in this case, it would be 3 cos of 3x. And you're done. You don't have to do any work. Some of you were trying to figure this out the long way. You just have to recognize it's FTC Part 2. You're deriving an integral. Therefore, you're doing essentially opposite operations, but there is a chain rule along the way. The reason I don't care about that 2 is because when I anti-derive it, it would be a constant term. And then when I derive it, the constant terms go to 0. Okay. Number 5 here, right? We've got to recognize that this is a trig inverse. Which trig inverse is it? Well, that's part of the challenge, but this one in particular is a sine inverse. So remembering that sine inverse, we are trying to fit the 1 over square root of 1 minus x squared. So we've got to get there. We don't have a 1. That's where you have to start with. So first, factor the 5 out so you find your 1. Take that 5 completely out of the square root, even out of the integral if you want to, but it's square root of 5, square root of 1 minus, and simultaneously, you need a quantity squared here. So that 6/5 that's there needs to be written as the square root of 6/5 x. So now I can say, well, my u is square root. You can break it apart if you want to. Square root of 6 over square root of 5 x. My du is then square root of 6, square root of 5 dx. So I get that out of there because I only really want to replace the dx. I only have to replace terms with variables in them. So root 5 over root 6 du is dx, and that's what's going to go in. So now I have the integral of root 5 over root 6 du divided by root 5 square root 1 minus u squared. The root 5s will cancel out. The du over 1 minus u squared, that is exactly the sine inverse. So automatically this goes to 1 over root 6 sine inverse u plus c. Final step, 1 over root 6 sine inverse of root 6 over root 5x plus c. Okay, so now we have our multiple choice questions, and these are a little bit different, depending on the version of the test you got again, but they're all assessing the same skills. Okay. First one, recognizing that if we're given a graph and we're told that, first of all, little f is there, and we're told that integral from 1 to 3 of little f is 2.3. That's telling me that the area under that graph is 2.3 from 1 to 3. So that space right there. And they're just confirming that if I derived big F, I would get back to little f. So therefore, FTC part 1 is a true statement. Okay. They're asking for what is f of 3 minus f of 0. Okay. So they're saying, well, what f of 3 minus f of 0, what is the integral from 0 to 3 of little f of x dx is really what the question is asking. Okay, well now, so I know 1 to 3 is 2.3, so this is equivalent to 2.3 plus the area from 0 to 1. Well, the area to 0 to 1 is just a rectangle, 2-unit rectangle, so it's 2.3 plus 2. It's 4.3. Done. Okay. Next one is one of these substitutions where you need to make sure you replace everything correctly. They're telling us what u is. So side work, u is x over 2. Don't try to do this by just guessing. Write it down. So du is then 1/2 dx. I don't need that right now, so I do 2 du is dx. That's a swap out for that. I need to account for the fact that I have an extra x, right? That denominator I need to deal with. So x is then equal to 2u. And I have limits of integration. U of 2 would equal 1, and u of 4 would equal 2. So now I have all the pieces that I need. So my limits changed 1 to 2. I have a 1 minus a u squared over a 2u times a 2 du. Simplify what you have. The 2's cancel out, so I'm left with 1 minus u squared over u du from 1 to 2. Answer choice A. Don't try to rush those problems. Okay, 4, another graph interpretation here. So the graph of a piecewise linear function, it's important because that means I can chunk it up and look at triangles and such. From -1 to 4 is shown. What is the value from -1 to 4? So I'm just looking for the area from here until here. So I can make into as many shapes as I need to. I've got a triangle, I've got a rectangle, another triangle, triangle, square. I need to acknowledge that the last triangle and the last square are negative. So I have a 1/2 base height, so 1/2 2 by 1 plus a 1 by 2 rectangle plus a 1/2 by 1 by 2 triangle minus a 1/2 1 by 1 triangle minus a 1 by 1 square. So that ends up being, let's see, 1 plus 2 plus 1 minus a half minus 1. So we get 3, 4, 2.5. Okay, very easy as long as you understand that the integral is just saying what's the area under that graph. And then you remember that the below is negative. Okay, this next one is a u sub. Okay, they're not telling you what u is, but you are using u sub and you are anti-deriving. So u is going to equal 4 minus x squared. Du is negative 2x dx. I need an x dx, so I just get rid of the negative 2. Right, so then I can rewrite my integral as negative 1/2 u to the 1/2 du, which if I add 1 and divide by the nu, I get a 3/2 for my exponent, and my fraction would become a negative 1/3 u to the 3/2 plus a c, and switch it back. So my answer is E. Okay, lastly, the tan of 2x integral. We did this a couple times in class. It's a double u substitution. So my first one is u is equal to 2x. Du is then 2 dx. And then 1/2 du is dx. Okay. So I put that in. I have integral of 1/2 tan u du. And then I pause because I don't have a rule for tan. So this is equivalent to integral 1/2 sine u over cos u du. Take the denominator as my next substitution. So now I'll say w is cos u. dw is negative sine u du. Get rid of the negative. So dw, negative dw is sine u du. So this is equivalent to the integral of 1/2 negative dw over w, which is where the ln comes from. So we get a negative 1/2 ln absolute value w plus c. Then we put back in our w and we put back in our u. So final answer, negative 1/2 ln absolute value cos of 2x absolute value plus c. So you get an answer of B. So hopefully that was helpful. I know it doesn't cover every exact question on the test. If you still have questions, please feel free to reach out.